Today's lesson is the introduction to our unit, which is on systems of linear equations. So we just finished the unit on linear equations, and now we're moving into systems of linear equations. And a system is simply, we'll be working with two linear equations at a time. And today we will strictly be graphing them, but later we'll be solving them in different ways. So the idea of this is we have two different linear equations, and if we graph them, so the green equation starts at -2, up 1 over 1. So if we were to graph that equation, and then if we graph the other one that starts up at 3, and then down 2 over 3, or up to left 3. So if we graph, the solution of this system is the point at which they intersect. And they intersect at the point 3, 1. So all of our solutions will have a value of x and a value of y. So to start out, I've given you a system of linear equations, y equals 2x plus 1, and 2x minus y equals 8. And then I give you this ordered pair, 2, 5, which always remember has x and y. And the question is this ordered pair the solution to this system? And we're not going to test it by graphing, we're going to test it by plugging in our x value for x in both equations, and then the y value, 5, in for y in both equations. And the test is to see if we create true statements or not for both equations. It has to work for both of them. So, the point 2,5, I'm going to rewrite the equation y equals 2x plus 1, and I'm going to rewrite it with my x and my y. So instead of y is 5. So 5 equals 2 times x, but x is 2 plus 1. So 5 equals 2 times 2 is 4, plus 1 is 5. Hey, so it checks for the first equation, but it has to check for both of them. So if I rewrite my other equation, 2x minus y equals 8, and then let's plug in my numbers. So 2 times x is 2, minus y is 5, equals 8. So 2 times 2 is 4, and 4 minus 5 is -1, and -1 does not equal 8. So that means no, this ordered pair is not a solution to the system because it does not work for both equations. So let's practice one more of these together, and then you can try one on your own. So I'll give you a system. 4x minus y equals -12, and -6x plus 5y equals -3. And then I'm giving you the ordered pair, -4.5, -6. So the question is, yes or no, is this ordered pair a solution to this system? And we're going to check by plugging in our x value and our y value into both equations. So 4x minus y equals 12. 4 times x is -4.5. And then minus y is -6. And we're testing, does that equal 12? 4 times -4.5 is -18, and then plus 6. Does that equal 12? And yes, it does. So it works for the first equation. Let's check the other one. -6x plus 5y equals -3. So let's change this to -6 times x is negative 4.5 plus 5 times y is negative 6. Does it equal negative 3? We should get negative 6 times negative 4.5 is a positive 27. And then 5 times negative 6 is a negative 30. And 27 minus 30 does equal negative 3. So it works for both equations. Therefore, this ordered pair is the solution to the system. If you were to graph this equation, the point of intersection would be this one. Alright, so now here's your last example for this type of question. I want you to pause the video and write it down and then try it all on your own and then come back and check your answer. Well, after plugging in x and y into both equations, you should have found out that it works for both equations. Therefore, if you were to graph those two equations, this ordered pair would be the solution. Now, we are actually going to solve our systems. So I've given you two equations, y equals 3/4 x minus 5 and y equals negative 2x plus 6. We are going to graph them both and find the intersection point, which is the solution to the system. So let's first graph our green equation. It has a y-intercept of negative 5. So let's put a point at negative 5. And then the slope is up 3 over 4. So up 1, 2, 3 over 1, 2, 3, 4. Up 1, 2, 3 over 1, 2, 3, 4. We can go backwards, down 3, left 4. And then, oh, we can go one more. Well, let's connect them. So we have our first equation graphed. Now let's graph the blue equation. It has the y-intercept positive 6. And then it has the slope negative 2. So it's going to go down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Looks like that's where it's going to intersect. Let's get a few more points. Graph the line. And the solution is the point at which they intersect, which I didn't draw that perfectly, but they do intersect at the point, it looks like over 4 down 2, so 4, negative 2 is the solution to the system. Alright, so that last example wasn't too bad, but the tricky part comes when equations are not written in the correct form. So you have to add a few steps. Just like this blue equation. It is not solved for y. So how do we solve it for y? How do we move a 3x to the other side? We're going to have to subtract it from both sides. So 3x plus y equals negative 1. Subtract 3x and subtract 3x. So y equals, now if we write our slope first, it's negative 3x, and then our y-intercept is negative 1. So we had to solve it. Now we can graph this equation that has the y-intercept of negative 1 and the slope negative 3. So it's going to go down 3 over 1, down 3 over 1. So I extended my points in both directions and I can connect my points. And now to graph this other equation, y equals 5. Remember that means that the slope is 0 to cancel out the x and the y-intercept is 5. So we find 5 on the y-axis and slope 0 means it's a horizontal line at 5. So now the point of intersection looks like it is right there, which is the point negative 2 up 5. So negative 2, 5 is the solution to my system. Okay, here is my last example. These two equations represent the system, but if you notice, neither one of them are written in the proper form, and these are both more complicated two-step equations. So we're going to practice solving them for y. So, starting with the blue equation, we need to get negative 12x to the other side. So we're going to add it to both sides. So negative 12x plus 4y equals 16. I need to add 12x on both sides. So 4y equals, I'm going to flip these so the slope shows up first, 12x plus 16. And now I need to divide everything by 4. So y equals 3x plus 4. And now we can graph that equation. So if we graph this equation, the y-intercept is at 4. And then the slope is 3, so I need to go up 3 over 1, up 3 over 1. Let's go backwards, down 3, left 1. And then we can connect the line. But now we need to solve the other equation. Same idea. Let's see, we have a negative 2x we need to get it to the other side. We need to add 2x to both sides. So negative 2x minus y equals negative 4. But I'm going to add 2x to both sides. Now be careful, on the left side, notice there's a negative y left over, not just y. And if I'm going to flip these numbers so the slope is first, it'd be a positive 2x and then a negative 4. And to get rid of that negative y, I need to divide all sides by negative 1. Which means my equation is y equals, this becomes negative 2x and a negative divided by a negative, so negative 4 divided by negative 1 is a positive 4. So I need to graph that equation, which starts at 4, and then the slope is negative 2, so down to right 1, or up to left 1. And the point at which they intersect, well, they share the same y-intercept at that 4, so they intersect at the point 0, 4. So sometimes you will get questions that are a lot of steps because you need to solve them for y, graph them, and then find the point at which they intersect. So there's your full lesson, the first lesson of our unit, solving systems of linear equations. Throughout the whole unit, every answer will be an ordered pair that has both x and y. Good luck!